Hi, welcome to the session on matrix transpose. In the last session, we have discussed about matrix multiplication. Okay, so now in this session, we'll be talking about finding the transpose of a matrix. Okay, so as we know, for finding the addition, matrix addition, and for matrix multiplication, there are certain rules, right? For addition, the number of rows of matrix A should be equal to the number of rows of matrix B, and the number of columns in matrix A should be equal to the number of columns in matrix B. Similarly, for multiplication, we have that the number of the columns of matrix first matrix of A should be equal to the number of rows of the second matrix. So that we have seen, and the resultant matrix that you go after multiplication is equal to nothing but the number of rows of matrix A and the number of columns of matrix B. Now, in order to find out the transpose of a matrix, there are no certain kind of rules that we are here. But only thing is that if we consider a matrix of suppose say size okay m, okay, or the number of rows is m, okay, and the number of column is n, then the matrix A m cross n, okay, if you do a transformation, then it becomes n cross m, where n is the number of rows and m is the number of columns. So it's just simply swapped, right? So simply swapped. The rows becomes the column and the column becomes the rows when you do a transformation of a matrix, right? So I'm showing you this diagram. So we have a matrix 3 cross 3. So typically the row of matrix A is 3 and the columns of matrix A is 3. So when you take the transport of matrix, it is also 3 cross 3. So the columns become the row becomes the column. Now, if you consider a matrix of 3 cross 2, right? The number of rows that we have 3, number of columns are 2, and you do a transformation, then the number of rows become 2 and the number of columns become 3. Just, it just swapped, right? Okay, now having said this, if you consider this particular matrix 3 cross 2, we have an element 2 3 4 5 6 7, and if you see in the transpose matrix, okay, so it should be 2 cross 3, right? This should be 2 cross 3, okay, so it is 2 cross 3. So 2 cross 3, we see that the row is 2 4 6 and next row is 3 5 7. What is happening you see here? Now if you see 2 3, okay, 4 5 6 7, now the row is 2 3, second row is 4 5, and the third row is 6 7. Okay, now this row becomes the column you see in next minute. So first row becomes the first column. So 2 3, the row that is there in matrix A, the transfer become 2 3, the column, right? 4 5, the second row becomes the second column, 4 5, or 6 7 becomes the third row becomes the 6 and the third column, or vice versa. If you take this first column, that is 2 4 6, it becomes the first row, 2 4 6, and the second column 3 5 7, it becomes the second row 3 5 7. So typically when you transform a matrix, the row becomes the columns, the column becomes the row, right? So based on this only, we need to deduce the logic itself, right? So if you see here, let us giving some value, right? So typically in C programming, if you talk about matrix, so index only started from 0. So we have index of 0 1 in the row, 1 2 1 0 1 2, right? So 2 is nothing but row 0 column 0, and 1 3 is nothing but row 0 column 1. Okay, now if you see in the transpose, with 2 is nothing but row 0 column 0, but okay, 3 is become row 1 column 0, just as I told you, the vice, just swapping of that. So that we have, so that, so if so 0 1, okay, that is what I was showing, the the column value 2 3, it's just it gets swaps itself, right? It gets swaps itself, right? So now you see here 2 0 0, we have 2, okay, right? And 0 1, we have 3. Now when you do the transformation, it says 0 0 equal to 2 and 1 0 equal to 3. Similarly, 1 0 we have 4, 1 1 equal to 5. Now this becomes, this 0 here, it becomes the 0 1 and 1 1 4 and 5. Yes, so let me tell you again. So if you take this matrix A, okay, right? 0 0 is 2 and 0 1 is 3, right? And 1 0 is 4 and 1 1 is 5. Then when you do the transformations, right? So 2 becomes, but the 0 value of the column, okay, now becomes the row value, right? And the 1 value, okay, on the matrix A becomes the, which was the column, now becomes the row. So we have 2 3. Yes, so 2 3, right? Then 0 1, okay, 1 0 it is 4, okay, 1 0 it is 4 and 1 1 it is 5. It just change up, okay, then it becomes 0 1 equal to 4 and 1 1 equal to 5. So simply we are actually, nothing but we are just swapping the, row and the column, right? That is what we have done. So typically if you see, this is what the code itself, okay. So first we will take a matrix, okay, then we enter the elements into the matrix, right? So this is what matrix A, okay, 5 and 5, okay, and we have taken MATT, which is for the transform matrix, right? And we have taken row A and row B, yes, and column A and column B. So row A and column A for the matrix A and row B and column B for the matrix, transformation itself. So I took the two loop and I'm just entering the value into the matrix A. Once it has been done, okay, I display the matrix, very simple. Okay, again the row and the column, and I display it. Then I do the transformations, right? So if you look at the transformation logic, if you see this, okay, so okay, the transformation matrix, right? If I take T, right, matrix T, I got the column and the row, okay, is equal to the row and column. Yes, because the matrix value, whatever is there in the row and the column will be it just you're swapping it. So column and row, and then we are displaying. So let us do it. Okay, let us do it. I have already created a matrix mat A 5 and 5 and mat T, which is for the transformation matrix, and I have written the code already for the matrix A, where I am taking the elements, okay, and then I'm again displaying the matrix. So let me save and let me execute it. Yes, so I said 1 2 3 4 5 6 7. Oh, sorry. Uh, I was doing a little bit faster. 1, 2, 3, 4, 5, 6. Right? So I have the matrix A. So 1 and 2, then 3 and 4, and 5 and 6. I hope it is clear to all of you. Yes. So this is what the matrix I have got. Right? Now, once I will transform this matrix, so the value that which should be 1, 3, 5 in the row again, and 2, 4, 6, right? So in the second row, right? Or in other way around, 1 and 2 it will come in the first column, 3 and 4 will come in the next column, and 5 and 6 will be coming in the next column. Okay, so let me write the logic for that. Okay, so what will be again, okay, for, yes, so just I'm simply copying this, copy, okay, yes. Now, right, so I have 3 and the row is 3, okay, the column value is 2. Okay, so now I write here mat t, okay, then I write I call A, yes, and this is I row A, yes. I'm just swapping, right, with matrix mat A, okay, which we have the row value, okay, and which we have the column value. Yes, right, done. Yes, I have able to do the transpose, right? Okay, yes, so my transform is done, and after that I need to display it. Okay, so for the display it, I just will be, oh no, for two times. Okay, so again for the display, yes. Now when you are going to display it, I said the row will become the column, column will become the row. Now this is 2, okay, this will be 3. Yes, it will just change, right? So now we have printf, okay, percentage d, comma. Yes, so what is the value of mat, control z, control z, control z, okay, mat, okay, t, then we have I row a, okay, I call a. Yes, okay, and printf percentage n, okay. Yes, so this is what I have got, right? Okay, so now, so let me save and let me execute. So 1, 2, 3, 4, 5, 6, 7. Again, I have done a mistake. Transpose, metric transpose, I have to save. Okay, fine, save it. So 1, 2, 3, 4, 5, 6. Yes, so I got it. The display. Yes, let me do it much in a better way so that it will be visible, because I'm not giving the tab. Okay, now I gave the tab. Let me save. Okay, now let me execute. Okay, so I give 1, 2, 3, 4, 5, 6, enter. So this is my matrix A. So 1, 2, 3, 4, 5, 6. Okay, and I got my matrices transformation 1, 3, 5. Okay, and 2, 4, 6. Right. So my 1, 3, 5, my row, my entire column matrix has become the row 1, 3, 5. Okay, 2, 4, 6 become the second row. Right, or my first row 1, 2 has become the column 1, 2, 3, 4 has become the next column, and 4, 6 has become the next column. Okay, so the simple concept is that we are just simply swapping the row and the column. So it's very easy in terms of matrix transformation. Just and you entering the element into the matrix. Okay, after that, just simply you take the same loop itself, right? Whatever for the matrix say, suppose it is for 3 rows and 2 columns, you just go for a loop for 3 rows 3 columns, whatever the size of the matrix of A. Yes, right, take that. So row, if it is 3, so I'm taking okay, row equal to 3, column equal to 2, and then after that in the matrix I just need to swap, right? I'm keeping the first value as column and second value as row. Okay, because my original is row and column, right? And then after that simply display it starting from row, starting 0, sorry, 2 and 3, because we have just swapped the row and value and the column, swap the row and the column, right? So that means the matrix that is A is of 3, 2 size. Okay, now in after transformation it becomes 2, 3, right? So the row 3 now has become the column 3, as and the column 2 has become the row 2. Yes, so this is very easy for the matrix transformation. I hope you are able to understand the logics. Okay, so thank you for watching my video, and if you are liking my video, kindly do share my video with your friends and kindly subscribe also. Thank you.